Okay, so every programming language follows these data structures, and VB.NET is no exception. So one of the most used data structures is the array. Now, it's considered that data comes, or data is, or data elements can come in a linear form and non-linear form. Okay, but most often than not, when we get data in a linear form, one way of handling it or implementing it is by the use of an array. Okay, so we say that an array is a linear data structure that is a collection of data elements of the same type. So if they are integers, they are all integers. If they are strings, they are all considered as string. Okay, so collection of data elements of the same type stored on the contiguous memory location. Okay. Hold on just a moment. Okay, sorry for that. So arrays are used to, or a collection of data, organize a collection of data elements of the same type stored on a contiguous memory location. Now, each data element has, or data item is called an element. Okay, so as we can see down here, we have the elements being indicated here. And then they are referenced based on their index. Okay, like we all know from level 100 and then last semester, okay, they are referenced based on their index. And the indexing starts from 0. Okay, so the first index is usually called the lower bound, starting from 0, and then ends with a last element having an index of n minus 1, okay, which we call the upper bound. Okay. Now the n represents the number of elements inside the array. So if there are 10 elements in the array, the last index will be 10 minus 1, which is 9. Okay. So this image explains that. Okay. Now let's look at how arrays are declared in VB.NET. So in VB.NET, we all know that in declaring a variable, we use the the variable name as an integer or a string or a double. Okay. Now in declaring an array, we put a bracket after the data type, or we can also declare it in this form, where we have the brackets after the variable name with specifying the value. Okay. Now, unlike other programming languages, for instance, Java, C++, okay, when we declare an array and we specify the number in there, okay, it is assumed that what the size of the array is being used here. Okay, so in Java, when we do this, it means that the size of the array has 5 elements. Okay. However, in VB.NET, when we do this, let's put this value here. This value is showing the upper bound value. When I say the upper bound value, I'm talking about the last index in your the index of the last element in the array. Okay, so in this case, we are trying to say that if we put 5 here, then it means that this array is going to hold 6 elements, because if you are starting from 0 to 5, what it means is that the last number, or we are going to end up getting 6 numbers if we are counting from 0 to 5. Okay, we are going to end up getting 6 elements. Okay. So we will look at that shortly. So that is how you declare your array in VB.NET. Okay, so this array is being declared as an integer. Another one, if you want to declare as a string, dim name as a string. If you want to declare as double, okay, the same format. Now, when you want to initialize an array in VB, you want to initialize an array in VB, you say dim number as integer. Okay. Now you use the new keyword at the time of initializing your array. So you can say dim num as integer equals new integer into bracket 5. Okay. Then now you specify the 6 elements inside your array. Are we all with me? Hello? Can you all hear me?
Yes, sir.
Yeah, we can hear you, sir.
Yes, sir.
Right. So that will give us, okay, the initialization of an array, declaration and initializing an array with 6 elements or size 6. Okay. All right, so let me just switch to the whiteboard and then talk about this concept in array, okay, when it has to do with VB.NET. Now, in VB.NET, all arrays are known as zero-based. In VB.NET, all arrays are known as zero-based. Okay. Now, if we say an array is zero-based, what it means is that the first index, okay, starts from 0. Okay, so that's to say that if we dim, let's say dim number as integer, and then we say, for instance, we put 5 here, or let me put 4 here. That is to say, this array has values. How many elements will this array have? Anyone?
Then 5.
5 elements. Okay. So 4, 6, 3, and 2. Okay. Now we say dim number as this. Now, if we say an array is 0 based, we are trying to say that the first index of the array will always start from 0. The second is 1. The third will be 2, 3, 4. Okay. Now, like I keep saying, if we say 0 base, it's because of what? The first index starting from 0. Okay. Now, previous versions of VB, that's VB6 and VB, were known to be 1 based. That means that their indexing started from 1. Okay, so they were considered in that case. So in that case, if their indexing started from 1 and you put 4 here inside your array, that means that what the array will have 4 elements. Okay, but with VB.NET, it's implemented based on a 0 base index. That means the indexing starts from 0. Now, another thing about VB.NET when it comes to arrays is that the in declaring an array, usually, or for instance, what we just did, integer, we specify what we call the lower bound to the upper bound index. That's the first index to the last index. Okay, that would have been the right way of writing an array in VB. Okay, however, this is what happens. This, because the value is considered, or all arrays are considered to be 0 based, okay, it ignores this 0 value. Okay, it ignores the 0 value. Just a moment. It ignores the 0 value. Okay, so this 0 value is considered as the lower bound. Hello, Matthew. All right, so the 0 is considered as the lower bound. This pardon my writing. Then this is considered as the upper bound. That's the last index. Okay. The upper bound, that's the last index. Okay. That's to say that we are ignoring the lower bound, which is 0 based, and then in declaring the array, we use the last index. Okay, so that's to say that if you are using the last index, and the last index is always considered to be n minus 1, then if n minus 1 is giving us 4, then our n, which is the array size, should give us 4 plus 1, which is equal to 5. Okay, so that's how come in VB.NET we put in the upper bound value when we are declaring the array. That doesn't mean the array has that number of values, but you add 1 to it to be able to tell the size of the array. Please, are we all here? I hope that is well explained.
Not very well, sir. I joined late.
So we are saying that with arrays in VB.NET, when you declare the array, like we have in this case, the value that is specified here as 4 is not the size of the array. It is rather the last index of the array. So if it's the last index of the array and we want to find the size of the array, then we are saying that what? If the last index is 4, and we know that to get the last index is always the size of the array minus 1. So if it's 4 and the size is n minus 1 will give us 4. Then n will be equal to 4 plus 1, which is 5. Okay, so in VB.NET, when you declare the array and you specify the upper bound, which is the last index, as 4, it's just to say that the array has 5 elements. If you specify it to say dim number as integer into bracket 9, that means the array is going to hold 10 elements because it's starting the count from 0 to 9. And when you count from 0 to 9, we are going to count 10 elements. Okay, so that is what VB.NET, how data arrays are handled in VB.NET. So there are some examples here. I'll talk about them when we meet face to face. We'll try at least one of them out. So in this particular example, we are trying to sum up some array of numbers, okay, or a list of numbers. So we deem I as integer and sum as integer. However, we initialize the sum to 0. Then we deem max, that's the array, as integer, okay, and we specify the elements. So 58, 68, 95, 50, 28, 3, and 89. These are assumed to be marks maybe a student had in 6 courses. Okay, so we want to sum up these marks in the program and get the grand total. Okay, so in order to do that, we are going to use a for loop, and we've talked about the for loop already and how it works in VB.NET. So with a for loop, we are saying that for I equals 0 to max.length. Now max.length is taking the length of this array. So the .length method is taking the length or the size of the array. And the length of the array is the number of elements in the array, which is 6. So from 0 to mark.length minus 1. So that is 6. The mark.length is 6. So 6 minus 1, which will give us 5. So from 0 to 5. Now if we count from 0 to 5, we are going to get 6 numbers or 6 elements. Okay, so we say console.writeLine max, and then we specify the location. So max into bracket I, where I is starting from 0. So I0 will be 58. So 58 plus sum is 0, will give us the new value of sum to be 58. Then it goes again when I is 1. because we are starting from 0 to 5. So where I is 1, max 1, which is 68. Then it adds 68 to the previous value of Sam, which is 58 plus 68, and gives us a new value. So this will continue until it adds all these numbers, and then eventually give us the grand total as the sum. So that's the first example. The second example is introducing two loops. One is entering the value of the array, and the other is displaying the values. All right, so now let's move to array list, another concept of an array. Okay, how to make use or to use an array or represent our arrays. Now, if we say a list simply means an ordered collection of elements, okay, or a sequential or linear collection of elements. Now, data structures, like I said earlier, are divided into two. There's the linear and the non-linear. So with the linear ones, they are seen as a list, okay, and they are in a sequential order. Now, these arrays or array lists have some operations that can be performed on them. Okay, you can search for an element in the array list. You can sort the list if it's not sorted. You can add an element. You can dynamically allocate memory to an element. You can remove an element and so on. Okay, so there are some methods in VB.NET that we can use to modify or perform operations on our array list. Okay. Now there are a whole lot of them. So there's the add method. So the add method, what it does is that it adds an object or an element at the end of the list. Take note, it will add it at the end of the list. And then there's add range. Okay, so add range is used to add elements of a specified range at the end of the list. Okay, or a specified collection at the end of the list. So end will add, the add will add only one element or an object at the end of the list, whereas the add range will add one or more than one, let me put it that way, more than one element, okay, at the end of the list. Okay, so a typical example, let me just demonstrate to you. Okay, so let's use this same example, then introduce another array, and let's say dim max. Sorry, this is supposed to be here. So dim max, say 2. Max 2 integers. We want to say this is 4 and 1. Okay. Now, if I take the first one, which is number, the first array, which is number, okay, and I do number dot add, then I specify the value I want to add. So let's say I want to add 9, okay, an element 9. My new value for array.number will now be these values here, okay, plus 9. So what is happening here is that it's adding is adding an element, okay, 9 to the last position of our list, okay, to the array number. It's adding 9 to the last position. Okay, that's how the add works. Now, when we come to the add range, so if we have, let's say, number dot add range, the add range doesn't add a number, but it adds what? More than, doesn't add an element, but it adds more than one element. So something like this, we can add the array max. So we can put max here, okay, because max is made up of what? 2 elements. And once we do that, our new value will now be this, and then add 412 to it. So if you go back again, you see that what? Add max. These are the elements for max, more than 2. So what will it do? It will append it to what? The array number in this form. So that's the difference between the add number, the add method, and then the add range method. I hope we all get it. Hello.
Yes, sir.
You are getting it. Yes, sir.
Please pay attention to these things, because your exams is going to be written. Your mid-semester exams is also coming up. They are going to be written. And these are some of the scenarios that I'll bring up. All right. Then we have the clear method. So the clear method is used to clear all records from the lists. The contain method is used to validate whether a specified object exists in the list or not. There's copy to, which is used to copy all elements of a list into a one-dimensional array. There's find. So the find is used to search. Take notes. The find method is used to search for an element from the list that matches the state and returns the first occurrence. Then there's find all. So there's find and find all. So for instance, if you are looking for, let's say, a list having a number appeared maybe 3 times, say the number 4 appearing 3 times, and we say find all into bracket 4, that means it's going to locate all the number 4 in our list. Or maybe we'll take this participant list and we have the name Abdul. Okay, so if we say find all into brackets Abdul, okay, it's going to give us 3 or 4 different Abdul. There's Abdul Hakim, Abdul Labran, Abdul Nasir, and Abdul Wahab. Okay, so the find all will find all the names that bear the word Abdul. Okay. But if you use just find, it will find the first occurrence in the list. So if we take the name Abdul, the first occurrence here in Abdul, the first occurrence here is Abdul Hakim. Okay, so that's the find, but the find all will find all the names that are bear the name Abdul. Then we have insert. Okay, now there's a difference between insert and add. Insert is not the same as add. The insert method inserts an element as a specified location of the list. Okay, whereas add will add the elements to the last at the end of the list, the insert. Yes, Daniel Amankwa, the handout has been ready since last week. So it's been ready since last week. I think I informed the class reps on the class reps page, okay, since last week. All right, so there is the yes, like I was saying, the add range. Sorry, the add. Okay, we'll insert the element at the end of the list, whereas the insert will find a position in your list and then insert the element. So for instance, if you are doing insert, insert can insert the value over here before the 5. Okay, because with the insert, it takes note of what? The index, that's the position. It takes note of the index before inserting the value. Okay. Then we have the insert range. So insert range also does the same thing, just like the range does. So that will also insert maybe some number of elements in the list starting from a specified location. Okay. Then we have remove. So remove is used to remove an element from the list. Then remove at is used to delete an element from a list at a specified location. As a specified location. So take note of that. At a particular location to remove the element from the list. And then there is another remove option, which is the sorry, there's also a remove option, okay, which will remove based on a particular range. Okay, based on a particular range. So there is remove range. I think I didn't include that in here. Okay. So let me just demonstrate some of these methods, like I was saying. So for instance, if you are using still the number and we say insert. Now this is how the insert works. First, you specify the index. Okay, so if I want to insert a number at index 0, I'll first specify 0. What number do I want to insert there? Maybe it's 5. Okay, so that will now give us, if we take the example on number, at index 0, we have 4. Okay, we have 4 at index 0. So if you want to insert 5 at index 0, it will place the 5 here. So we end up getting this, because what we are inserting five at index 0. Okay. Then here is index 0, that's the position. Then, like I said, the remove. So if we say number number dot remove. Number dot remove, and you put the remove 4. Okay, what it's going to do is that it's going to take 4 out of our list, and we'll end up getting this. That's 5, 6, 3, 2. Okay, if we say remove at, if we say remove at, now with the remove at, what you do is you specify the index. So if I say remove at 4, now this 4 doesn't mean we are removing the element 4. Rather, it means that we are removing at index 4. And index 4 is what? The value 2. Okay, so we are removing 2 from our list. That's what it means. Okay, then there's remove range. The remove range means that you specify the index and from what range you want to remove from. Okay, or what number of values you want to remove from that range. So those methods are all available. Then we have the reverse. So the reverse will reverse the order of the element, and the sort, which will sort out the elements in ascending order or increasing order. Then to array, which will copy the element from the list to a new array. Okay. So there's an example here implementing these methods in VB.net. Any question? Any question on the arrays and the array list? Any question before we move to functions and subs?
Yes, sir.
Yeah.
Sir, please, you said that the array is it starts from 0.
Yes.
So I was thinking that when
the index of an array starts from 0.
Okay,
yes, you
so
can go on.
Okay, I was thinking that because of that, let's say when we are removing array, or yeah, please, if you can give me the command where we add the where you write the add the code. For example, that I will.
Yeah.
Yeah. Yeah, where you are adding. Okay, let me look at where you are adding this one. Yes, I was thinking that because the index is the index starts with 0, it will add this instead of all this number to add about it will add 3, and instead of 4 2, it will add maybe 4 0 4 1. That's what I was thinking.
I don't get it. I'm lost. Which of the examples are you talking about?
Add range.
Add range.
Yes, please.
Yes. So the add range, the add will add only one element at the end. Yes. However, the add range will add more than one element. And the add range, we are adding a range, okay, which is max. And max is made up of 2 elements. So when we add the max, we are going to get these 2 elements, 4 and 1, being added to the end of the last element in the array number, which is the last element is 2. So it will add 4 and 1 to it because we are adding a range of numbers or a range of elements. I don't know if that explains it.
Yeah, I said I was thinking that because the index starts from 0, it will add maybe 0, 4, 1. That's what I was saying.
For the add range,
Yes, please.
no, so when you are adding an element. Take note, this is the element. The values in your array are known as elements. Please, we've done this in Java, and you've done it in
Yes.
data structures. Then the index is the position. The index is the position. The indexing starts from 0, 1, 2, 3, 4. But the elements that you see, it's just like you have a list, okay? Or you are going to write exams. You are going to write exams and you know that, okay, this is your seat number. Okay, but you have your name. There's the attendance list will come and the seat number assigned to everyone. So your seat number determines where you sit. So if we do add, if we have to, let's say the classroom is, there are 19 students in the class, and we use a method, add a student. Now that student will be added to, will be placed at the end of the class. So that student will take seat number 20.
Okay.
You get it?
Yes.
That's if we use the add. Now imagine there's an issue in maybe one lecture or one exam center, and that exam center has 5 students, and they have to move that 5 students to where the 19 students are.
Mhm.
In that particular case, we'll use the add range
Range. Okay.
because we are taking more than one student or more than one element. So with that one, we'll use add range. Then the students will start from seat number 20, 21, 22, 23 to 24.
Okay.
Hope that's clear.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
It is the insert one that, with the insert, that is when you specify the location, okay, where you want to. That's where you use the index.
Okay.
That's where you use the index. So let's say just the same scenario, the exam hall scenario. So there's an exam taking place, 19 students, but you realize that seat number, say 3, there's no one sitting there. Okay, seat number 3, that's position 3, index 3. There's no one sitting there. Okay, and then we bring in a student. Now we want that student to sit or to fill that position, which is seat number 3 or index 3. So what do? We put 3 there, where the 3 means the position. Then we specify the name of the student who sits there. Okay. However, if we are supposed to use the add will rather put the student at the back, at the end of the class, which is seat number 20. But the insert will now fix the student at the place or the seat number we want to move that student to. Is that clear?
Yes, sir.
Any other question before we move to subs and functions? All right, so if there's no question, let's look at subs and functions. Now, so the beginning of the class, we talked about the VB program structure. Okay, in the program structure, we said every VB program should have at least one procedure, okay, or one or more procedure. and they should always have the main procedure. Now we said procedures are in VB are divided into two. We have the sub and then we have the function. Okay, so we use the sub in the program when we are not, or they perform two different roles, the program. Okay, functions are just like subs, or we can say subs are just like functions. The only difference is that when it comes to subs, okay, the functions have return value, but the subs do not have return value. Okay, so inside the function, you see something like return, then there's a value there, maybe return 0 or return this. But with the sub, there is no return value. That's how come when we write a program, sub main, okay, sub main, you don't see anything like return at the end. There's no return before we end the sub. However, if it is a function, so in this function, this example, for instance, model find sum, we create a function. The function name is sum of two numbers. So we take the two numbers, n1 and n2, okay, and all as integers. Then if we want to find the sum, we say that's what? n1 plus n2. Now after that, we return the sum, the value of the sum. After you've added n1 and n2, you return the value. So return sum. Okay, so this return value here is because this is a function. Now with the subs, there are no return value. Okay, so basically that's the difference between functions and sub. Yes, I hope that is clear. So let me get a response.
Yes, sir. Yes, sir.
So that's the difference between subs and functions. Now, when declaring your function, okay, or your sub, you specify, this is the syntax. You have the SS specifier, which we'll talk about shortly. Then you have the function name or the keyword function, followed by the function name, and then the parameters to put in there. Then you have your return type. So if it's an integer function, you are going to return an integer. If it's a double or a float, you return a double or a float. If it's a string, you return a string. Okay, in that order. So if you look at this example, back to it again, sum of two numbers, that's the name of the function. So we take it by value. So the value of the first number as integer, value of the second number we want to sum as integer. Then the entire function is also taken as integer. Then we declare the sum variable, initialize it to 0. We add the two integers and we assign the value to the sum. Then eventually we return the sum. Okay. And the same way, if you want to subtract two values by value int n1, sorry, n1 as integer, n2 as integer, and then we subtract n1 minus n2, and then we indicate or return the value after we subtract. Then we said the subs are also procedure, and it's a separate set of code that are used in VB.NET to execute specific tasks, but it does not return any value. take note, it does not return any value. So the sub is enclosed by the sub and then the end sub statement. Okay. So they work just like functions, however, they do not have a return value. So an example 2 here on how the sub works. Any question? Any question? All right, so if there's no question, let's look at classes and objects. Classes and objects. So we've said that, or we've learned from Java 1 on what classes and objects are. Okay, now we said that what VB.NET is an object-oriented programming. So if a programming language is considered to be an object-oriented programming language, then there's a need for us to look at it from that perspective, okay, of classes and objects. Now we said a class simply has to do, or we define a class as a template or a blueprint, okay, which is made up of properties or attributes and behaviors, where the attributes or properties are the data elements, and then the behaviors are known as the functions or the member functions. Okay. Then we also went ahead to talk about objects. We said that objects are instances of a class. An object is seen as an instance of a class. Okay. Now in VB.NET, in order to define a class, we specify the class keyword, then the class name, then at the end of it all, we end with what? The end class. Now, VB provides a lighter version of classes, which is called the structures. Okay, C++ programming also does that. Okay, and this is how structures are represented. Now, we said classes are made up of members. Now, those members are the properties, and those properties describe the class data. And then another class member is known as the methods, and the methods define the behavior of the class. And then also we can have events that produce communication between classes and objects. Okay. So an example has been given here. Now, the objects, like we said, are instances of a class. Over here, it says here the basic runtime units of a class. Okay, that is to say that if we have a class car, okay, the class car has a speed limit, okay, mileage, the number of wheels as its attributes. Okay, now that class can be accessed by an object, where the object can be, let's say, a certain model of car. So let's say a sedan car or an SUV or a 4x4 car. Okay, now those 4x4 cars or sedan cars are instances of the class car, or their basic units of the class car, where the class car is like a generic description of every car. Every car has a speed, has wheels, has some chassis number, and so on. Okay, so an object of the car can be a sedan car, SUV car, and so on. Okay. Now in VB.NET, when you want to create a class, you specify, there's what we call the access specifiers. Okay. Then you have the shadow. These are all optional. Then we have must inherit, non-inheritable, and then partial. Okay. You can bring all these optional properties before you declare your class. Okay. Now, what are these access specifiers? These access specifiers are access level of the class, the access level, or they define the access level of the class. That means the class can be private, it can be public, it can be protected, it can be friend, or it can be protected friend. And like I said again, these parameters are all optional. Okay. Depending on when you are creating a class, you decide to use them. Now, if you use a class and you say the class is public, it means that the members of the class can be accessed by any other members or any other code in the same assembly or other assembly or other classes, okay, or other methods. Now, if we say it is private, then it means that it can only be accessed in the same code or in the same class code. Okay. Can be accessed in the same code in the same class. Now, if it is protected, it means that it can be accessed by the code in the same class or in a derived class. If we say a derived class, it means that there's some form of inheritance taking place there. So there is a parent class and there's a child class. So it means that the child class can also access that member or type. And then there is the friend. Okay, so the type which the access specifier, which is friend, says that that type can be accessed by any code in the same assembly, but not on a different assembly. Okay, so that's the opposite of the friend. Sorry, the friend is the opposite of the class. Okay, then a protected friend can be accessed by any code in the same assembly or by any derived class in another assembly. Okay. Then we have the shadows, which are also optional. They represent redeclaration of variables and hide identical elements name. Then must inherit also is used when a class can only be used as a base class. We say a base class as can be used as a parent class. So if it's a parent class and we add must inherit to it, that means that the children classes can inherit from that class. Then another parameter is then not inheritable. So not inheritable, when we add it to a base class, it means that that base class we cannot inherit, or the derived class or the child class cannot inherit from it. And then we have the partial, which means that it has some partial, or it represents partial definition of the class. And then finally, we have the implement, which is used to specify the interfaces from which the class inherits. It's also optional. So there's an example here. We try that as well, where we meet face to face. So I think when we look at this this code, I'll explain the other parts of the slides. Okay. And then the final thing I want to talk about is the exception handling. Okay, exception handling. So an exception, like we all know from last semester, is an unwanted error that occurs during the execution of a program. It can be a system exception or an application exception. Okay, so now an exception occurred due to different reasons. Okay, now two of which has been given here. One is saying that an exception may occur when a user has entered data or performed a division operator, such as dividing by 0. Okay, it causes an error. It causes an exception. Another type of exception happens when a connection has lost, or when a connection has been lost in the middle of communication. Okay, so maybe trying to connect to a database and you've lost that connection or the internet. Okay, an exception or an error message should pop up giving you an exception. And then finally, the system memory running out. Okay, so sometimes you can be using your machine or something and some memory is running out. And a message pop up, that can be considered to be an exception. So just like we learned in VB, in Java, the same keyword, try, catch, finally, throw. Okay, are the same keywords we use in VB.NET to handle exception. And in doing that, there are two main types of exception in VB primarily, like we said. There is the system.system exception, and there is the .application exception. The difference is that the system exception is predefined. Okay, so these are exceptions which have predefined classes in your VB.NET program. Okay, they are system generated. So a typical example is when you are dividing by 0, when an index is out of range, Stack Overflow expression, and so on. Will give you a system exception. Then application exception are considered to be user-defined. User-defined. So when the programmer decide or the developer decide to put an exception message in the program. So for instance, when you are trying to log into, let's say, a particular application and you are entering a wrong password. Okay, a wrong password. It's a programmer defined exception, or programmer, or it's an application exception. So the programmer will put in there that, okay, your password should contain at least 8 digits or 8 characters. You should have a digit, an uppercase, a lowercase, and a symbol. Okay, so that is a typical example of an application exception. And there's some codes here to implement it. Okay. So I'll end it here. Hopefully when we meet next week, we'll write out some of these codes. Next week, the full-timers will be writing their mid-semester exams because they were able to meet last week. But next week, we'll rather be writing out some codes. Okay, so that we'll move our mid-semester exams to next 2 weeks, or sorry, next 3 weeks. That's week 10. Okay, so please take notes. Yes, Arnold, your hand is up.
So it's about the class.
Yeah.
You know, there's this we have a when you create a class, you have a sub created in the class. Right? Let's assume it's a program you're writing. There's going to be
when you create a project.
When you create a project. Okay, when you create a project and you create a class, you have to create a sub main in that class. Like what we have the sub main over here. Now, when does the sub main become a share sub? a share submain. What does that? What's the meaning of the share submain?
We've not used any example like that, so I want to find out where you saw the shared submain.
I was reading on the class, and the first program they did about the rectangle, the same rectangle calculation, but we use a share sub instead of submain in the class.
Okay, so the shared sub or the shared keyword there, okay, in VB.NET, if you use the keyword, or let me say it's an optional word, okay, it's optional, just like we saw with the public static specifiers and all that. Now in VB.NET, if we say a sub or a function is shared, it means that that function is not part of an instance. That's to say that some fields within that function are not considered to be an instance type.
Okay.
Yeah, I don't know if you are getting what I'm trying to say.
Yeah.
So let me. Do I have it in this code? Okay, I don't have it here. Trying to look at it if there's an example with a shed. I don't know if it's been used for the main method, but I know that it can be used for other declarations and other functions in the program. But
Okay,
I've been using it for the sub main. For that one, I'm yet to see an example like that. But it can be used for declaring integers. So you can say maybe shared number as
integer.
As integer equals 0.
Okay.
Yeah.
Okay. Thank you.
Those options are there. Yeah, you're welcome. Is any other question before we end for today? All right, so there's no question. I think we'll call it a day.